Okay, in this video we're going to look at finding the angle between two vectors. And before we do that, we have to talk about something called a scalar product, which sometimes we will refer to it as a dot product. And this is a calculation between two vectors. So let's define vector v to have components v sub 1, v sub 2, and v sub 3. So let's suppose that we are talking about a 3D vector. Of course, if we were in 2D, we would just eliminate that third component. Okay, and vector w, suppose, has an x, a y, and a z component of w1, 2, and 3. So this thing called the scalar product, it uses a dot. That's why it's called a dot product. Now it's kind of dealing with multiplication. I know you're thinking, well, product means multiply, and yes, we are going to be doing some multiplication, but what you're going to have to do is we're going to multiply together the pairing of the two x components, plus we're going to multiply together the two y components, and then you're going to add on to that the z components. So this is known as the scalar product. And if you look in your formula sheet here, they give you this. This is in terms of v and w. So again, this is given. And there's actually two formulas that they give you for the scalar product. This is the second of the two that are given. We'll talk about the first one in a moment. So let's just look at a quick example here. Okay, so suppose we wish to find the scalar product or the dot product of these two vectors. So guys, it's really easy. All we are going to do, and we can use some notation here. So the notation is to put a little dot in between these two vectors. Since we don't have letters representing these vectors, we'll just write the vectors themselves like that. So all we're going to do is we're just going to multiply together the x components, plus we're going to multiply together the y components, and then the same with the z components. And then you're just going to clean this up, and your answer is going to be a number. Your answer is not going to be a vector. All right, our answer here is just a scalar. Okay, notice how we said it's called a scalar product, so we're getting a scalar, okay, which is just that magnitude. All right, there's no direction there, so it's not a vector. Okay, so that is our scalar product. Now, suppose we want to take this a step further, and we wanted to find the angle between these vectors. All right, so to find the angle, which we're going to call theta, between these two vectors. Now keep in mind these two vectors, they're 3D, they're in space. We're not able to really visualize this very easily, but we are able to pick up a vector anywhere and move it as long as we are not changing its length or its direction. Okay, so if we were to position these vectors in such a way that they were each starting at the same point, we can try to find the angle between those two vectors. Okay, so if we needed to do that, this is the formula that we're going to use. This notice is given to you in your formula sheet as well. And so what we're really, again, what we're trying to find here is we're not going to be able to do this, of course, accurately on our diagram here because we're talking about vectors in space, but we're really looking to find the angle between two vectors if they have the same starting point. So again, imagine taking these two vectors that we were given and moving them in such a manner where we just line them up. Again, we're not changing the length, we're not changing the direction, but we are just moving them in such a way where they have the same starting point. So we're trying to find the angle between them. So how do we do that? Well, here's the formula. We can see that it involves a cosine and the angle's inside there. Notice that the numerator in this formula is the scalar product. So we've already found the scalar product. And notice in the denominator we have, remember that absolute value symbol means the magnitude. So what we really have here is the magnitudes multiplied together. All right, so let's do it on this example. So we said how already we know that I'll go up here. Cosine of theta is equal to negative 12, right? That was our scalar product that we did in the previous step. Now, in our denominator, we need to find the magnitude of each of those vectors. So, we need to find the magnitude of our vector 6, 2, 1, and then we need to find the magnitude of our vector negative 3, 1, 4. So recall we said this is where you're going to put all the components into Pythagorean theorem. So I'm going to square all of these components, so 6 squared plus 2 squared plus 1 squared, and then down here, negative 3 squared plus 1 squared plus 4 squared. So when we clean these up, we're going to have 36 plus 5, so that's a square root of 41 for that guy. And then down here, 9 plus 1 plus that's 16. So that is going to be radical 26. So what we really have here, if we go back to our formula, we have radical 41, and then we have times a radical 26. So it's not a dot product in the bottom. This is just a regular product or multiplication. So what we can really do is we can multiply that 41 and that 26 together. If we do that, we're going to get 1066. So this, keep in mind, is equal to the cosine of our angle. So to find our angle, recall from when we studied trig, we need to do inverse cosine. And guys, when we talk about vectors, I'd say 99.9% of the time, we're going to be in degrees. So make sure your mode is in degree mode. So we have negative 12 divided by the square root of 1066. And if we were to round to the nearest integer, we would end up with 112 degrees. So that is the angle between those two vectors that we were trying to find. And notice how we needed to use the scalar product within that formula. Okay, another example here. Let's suppose we want to find the angle between these two vectors, and this time our vectors a and b are in unit vector form. Also notice how we're talking about 2D. Now, right away, I would suggest getting it out of the I and the j form and putting it into component form. So when you write this in component form, notice how I am dropping the I and the j. All right, I'm not going to put that in my column vector, also known as my component form. Okay, the I and the j gets dropped. So let's find our dot product between these vectors. So this is going to entail us just multiplying the like components together. So I have x components and I have y components. So if I multiply these together and then add them, I'm going to end up with 63. Now, I also know that I need the magnitude of these two vectors. So my magnitude of A, well, notice that this is a nice triple. It's a 3, 4, 5 triple. So my answer, my length, my magnitude would just be a clean 5. Not square root of 5, just 5. And likewise, we have a 5, 12, 13 triple. So 13 would be the length of vector B. So when we multiply those two together, you're going to end up with 65. So we know the bottom part of our formula looks like this. So that is going to give us 65, right? So let me just jot down here that we're really doing the 5 times the 13 to get 65. So our formula says the cosine of the angle is equal to the dot product of the two vectors divided by the magnitudes multiplied together. We said how that's already 63, we know, and that's 65. So sometimes, by the way, you will have a question ask for the cosine of the angle. If we wanted the cosine of the angle, we would be done. But we want the actual angle. So we're going to do inverse cosine of 63 divided by 65, and that's going to give us 14.3 degrees. Make sure you're checking that. All right. So if we were to just take this a step further and just look at a visual, so if we were to draw these two vectors in standard position where they start at the origin. So the vector 3, 4, I'm going to the right 3, and then I'm going up 4. Let's say that's 4 right there. So here is my vector 3, 4. Okay, and this vector we are calling A. And my vector B has components 5, 12. So let's suppose here's our 12. So that's way up here. Okay, and if we draw that from the origin, all right, that's my vector B. The angle we're trying to find is this little sliver of an angle. We can see that it looks pretty reasonable at that 14.3 degrees would make sense. Okay, so the idea behind finding an angle between two vectors is where you draw these vectors from the same starting point. And then it's just a matter of using this formula to find the angle. So what if two vectors are perpendicular? Well, if two vectors are perpendicular, of course, that means that if we draw it from the same point, we know there's a right angle. So it means the theta would be 90 degrees. Well, what happens to our formula? So recall this is the formula here for finding the angle between two vectors. So if our angle is 90, then what happens here, well, the cosine of 90, if you think about your cosine graph, cosine of 90 is 0. So we have 0 equals this entire right-hand side. And if you put this over 1 and cross multiply, you end up with 0 is equal to the dot product. So the big takeaway here is that if two vectors are perpendicular, the dot product is going to be 0. Let's write that down. Okay, so if two vectors are perpendicular, we know with complete certainty that their scalar product is going to end up being 0. Now, let's look at an example where we apply this. Okay, take a moment and copy this down. We're looking to find this symbol lambda if, now lambda shows up right here in this b vector. It's just a coefficient. It's just whatever the z component is for this b vector. So we have these two vectors given to us for a and b, and we're told that a plus b is perpendicular to a minus b. So what I suggest you do, just like I told you before, let's rewrite this into component form. So there's our a, right, would be 5, negative 3, 7, and our b has components 1, 1, and lambda, which is what we're trying to find. So we are given here the fact that a plus b and a minus b are perpendicular. So before we think about their scalar product equaling 0, we need to find a plus b. So vector a plus b, it's pretty simple. You're just going to do exactly what you would think you need to do. You're just going to add straight across, right? All of a's numbers with all of b's numbers. So that would give us 6, negative 2, and then 7 plus that lambda. And then our a minus b, same thing, except now we're subtracting. So we're doing 5 take away 1, negative 3 minus 1, and then you'd have that 7 minus lambda. So if we are told that these two vectors are perpendicular, then we know that the scalar product has to equal 0. Guys, this is probably the #1 most assessed concept in all of vectors. The idea that if two vectors are perpendicular, their scalar product is 0. So you really got to make sure you have this down. So what we need to do now is find the scalar product. And we're going to set it equal to 0 since we know they're perpendicular. So to show our work here, we have 6, negative 2, 7 plus lambda. I'm going to use my scalar product symbol, right, that little dot. So I'm writing down my two vectors, and I'm going to set this equal to 0. Okay, and now I'm just going to solve this equation. So we know that the scalar product means we're going to multiply these two x's together, and you don't have to show that it's 6 times 4. You could just write 24 plus, and now I'm going to multiply these two together. That's going to give me 8. And then plus, and now what I need to do is multiply 7 plus lambda times 7 minus lambda. Well, since we have opposites, We know the inner and the outer are going to cancel. So we're going to have 49 excuse me, minus lambda squared equals 0. So let's clean this up. So that's going to give us 81 minus lambda squared equals 0. How about we bring everything over to the other side? So lambda squared minus 81 would equal 0. Well, that's going to give me lambda is equal to plus or minus 9. Okay? Okay, and finally, real quick, let's revisit our scalar product formula. We talked about how this is the formula we're going to use if we know the components of our vector. We also talked about how this is the formula for finding an angle between two vectors, and we talked about how the scalar product shows up right here in the numerator. Well, if we put this over 1 and cross multiply, we would see that the scalar product is really equal to those two magnitudes multiplied together and then times the cosine of the angle. So please note in your formula sheet that this is given to you. And well, why would you want to ever bother using that? Well, perhaps we don't know the components of a vector. Perhaps we know the magnitudes, and we know the angle between two vectors only. All right, and we don't actually know the components. So just keep it handy. Just remember that there might come a time where you have to use it, but it involves knowing the angle between the two vectors and the magnitudes of the vectors and not knowing the actual components. Sorry this video was so long. Bye-bye.